So we are on our chemistry solutions unit. We are going to look at concentration. Whoa, wrong thing. We are going to look at concentration calculations. So we're only going to do 3 easy cheesy examples. Yesterday we learned about how to describe our solutions qualitatively. So qualitatively is one of our words here, our terms. So Sarah, Ava, this is going to be on YouTube, me scolding you in class. So what does the word qualitatively mean? Yeah, if you were looking at a pencil, you could say that it was yellow. That would be one of its qualities. We were talking about the qualities of solutions. How did I say that you should describe your coffee in the morning now? Dilute, concentrated, so those are qualitative descriptions of that solution. What were some other qualitative descriptions that we talked about? Yeah, we don't see the different parts of it, so our solutions are uniform throughout. Some other terms we learned. Homogeneous. We learned that we could describe our solutions as being saturated. We could describe their miscibility or immiscibility. So those are all qualitative traits. We're going to look at how to describe them quantitatively. What do you think that means? Numbers. Perfect. So we're going to be looking at amounts or quantities. There are many different ways to describe concentrations of our solutions. So those would be quantitative amounts. We're only going to look at one of those today. So today we're going to look at molarity. So we can describe the concentration of our solutions using molarity. It's probably the most common one for chemistry, unless we're talking about really dilute solutions. So molarity means the moles of solute that we have dissolved per liter of solution. So its units are simply moles, MOL, over liters. So moles over liters. We often see those units just as a big letter M. So you need to be able to translate what does this big letter M mean. It means moles in liters, moles over liters. So far so good? So that's kind of our theory part, and we'll do some calculations now. So example 1, what is the molarity of a 250 milliliter solution containing 10.6 grams of copper 2 bromide? So our goal is to get the moles over the liters. So we're going to use unit analysis again. Kate, are you okay, Katie? Chemistry is hilarious today for Katie. All right, so moles of solute. So what's our solute? What are we dissolving? Yeah, we're dissolving next. This is our solute. And we know how many moles of copper 2 bromide we have. Yeah, so we've got mass, Michaela's saying, so we've got to find moles. What do we need in order to convert that mass to moles? Divide it by the molar mass. So let's get a formula for copper 2 bromide. What's copper 2's charge here? 2. How is that? What is bromide's charge? -1. So we do our crossover. We're going to have 2 bromides and 1 copper. So now we can calculate its molar mass. If someone wants to crunch that number for me. What is our molar mass of our copper 2 bromide?
I got 223.2.
200, sorry. 223.8. And what are our units of molar mass? Grams per mole. Michaela got something different?
Well, I got 222, but I got 35.
Okay, let's double check. What's our molar mass of copper? 63.55 plus 2 times what's bromine's molar mass? Say that again, Michaela?
7 grams per mole.
I don't know. 29.90. Some weird punching stuff ends. So 3.5.
Multiply by 2 because there's like
Because there's 2 bromines.
oh, okay, got it.
Okay, so we know our molar mass. We've got to convert our 10.6 grams to mass. So Ava already told us how to do that. We are doing what with our molar mass? Putting our moles on top. And we're dividing by 223.35 grams. What happens to our grams? They cancel it. So now we've got our moles on top. Just like we want. And what do we want on the bottom? Meters. We have been given milliliters.
How many milliliters in a liter?
How many millimeters are in a liter? It's a famous question. Age old.
10, 100. I'm going to guess 100.
There would be 1,000 milliliters in a liter. So how are we going to convert our milliliters to liters? Divided by 1,000.
Like, I have a question that is very dumb. You're probably going to get mad, but when you're finding out the molar mass of copper bromide, why would you do like copper bromide is really expensive instead of having to switch the charges first? They usually don't switch the charges.
Because this is the formula of copper 2 bromide. There's 1 copper and 2 bromides. And that's always how they combine. They combine in that ratio because of their charges. So we have to use the formula of copper 2 bromide to find the molar mass of copper 2 bromide.
Oh, yeah, okay.
Does that make sense? Okay. So Sam's saying for our milliliters to convert to liters, we need to divide by 1,000. I just like moving my decimal over. So if we're dividing by something, Janessa, with 3 zeros, we should be moving our decimal over 3 boxes. 1, 2, 3. So there is our equivalent volume in liters. So where do we want the liters?
On the bottom.
On the bottom. So we are going to be now dividing by 0.250 liters. So do we have the units we want for molarity? Yes. Yes,
How do you spell that, Miss Russell?
I don't know. It's unclear because it's not actually in the dictionary.
If you type it into your phone, the way he spells it says wrong, the way I spell it does not say it's wrong.
Okay, so at any rate, we're in chemistry. So we're taking our 10.6 grams. We are dividing it by 223.35, and then we're dividing it by 0.250. And if you need to do this in baby steps, You can find the moles, equal that out in your calculator, and then divide by volume. So it's totally up to you.
Miss, this is how we end after baby step, right?
Yes, that's a baby step. So we get 0.1898, etc., moles over liters. Janessa, we should be thinking about significant figures. So how many significant figures should our answer have? 3. So what are we going to round this number to? 190. And what are its units? Moles over liters. MOL over big letter L. Or we could just call them big letter M's. So far, so good? Okay, this question's a little bit different. This is question 2 is pretty practical. So I need to get ready for a lab for you guys. I know I need to make a liter of solution, and I know it needs to have this concentration. So I can't count out 3 moles because I would be counting for several lifetimes to count out 3 moles and then divide it in 1 liter. But what I can do, Sarah and Eva, is I can weigh this stuff. So how many grams of sodium sulfate do I need to weigh out to make 1 liter of a 3 mole per liter solution? So to find grams, first I'm going to find moles. So I can take my concentration. And if I want to get rid of liters, and liters are on the bottom, I can multiply. So I'm going to multiply by the volume of solution in liters. What happens to my liters here? They cancel out.
So you multiply it by the molar mass.
And then I've got moles, and to go from moles to mass, we're going to do what Sydney said. We're going to
Multiply it on here.
multiply it by the molar mass of sodium sulfate. So let's get sodium sulfate's molar mass.
It should be 1.2
Katie already knows it, so 22.99, that's the molar mass of sodium, and there are 2 of them. I don't have sulfur memorized. 32.07, so that's 1 sulfur plus 4 times 16, because there are 4 oxygens. So 142.05, I should have just trusted Katie, so we're going to multiply that by our molar mass. And its units are grams over moles. So what happens to our moles? They cancel. Boom, gone. And now I have the mass of my sodium sulfate, which is what I wanted to figure out in the first place. In my calculator, I should do my 3 moles per liter times by 1 liter, that doesn't change it mathematically, times by 142.05. I'm going to have to weigh a lot of sodium sulfate out. So 426.15 grams.
And that's how any baby step.
But 3 moles per liter is a lot.
It's a lot. It's a pretty concentrated solution. And thinking about significant figures, I should only have 3. So 142 grams of sodium sulfate should be weighed out.
What's that? 140. Yeah, it's 426.
426. Thank you.
Yeah.
426. Thank you. So that's a lot. That's going to be a pretty concentrated solution.
What color would that be?
Colorless.
You just put blue dye and make it purple.
Because,
You can tell you want to.
okay, next problem. This is probably our most complicated problem. So remember when we were doing net ionic equations and only a certain portion of our compounds reacted and everything else was spectating? So often when we look at molarity, we often just express it in terms of molarity of one particular ion. So here, that's what we're going to do. What's the molarity of ammonium ions if 1.48 grams of ammonium phosphate is dissolved in 2 liters of water? We got to get rid of the phosphate somehow. We got to get rid of the phosphate somehow. So first, we're going to figure out our moles per liter of phosphate. Of ammonium phosphate. That's kind of going to be our first rule, because that's what we weighed out. Remember, Sarah, that our ammonium phosphate ions are inseparable. They are electrostatically bonded as a solid. We're not going to be able to rip away the ammoniums from the phosphate and just weigh the ammoniums. We have to weigh the whole compound. So that's going to be our first step. So on our top, we want to have moles. So we're going to take our 1.48 grams, and we want to convert that 1.48 grams of ammonium phosphate to moles. So how do we do that? Sarah?
I think you will probably do something with the water.
Sarah was too busy talking to Ava, so she was not even paying attention. Say that again, Brody. You divide it by grams over moles. So we need the molar mass of ammonium phosphate. And as punishment to Sarah for not paying attention, she's going to calculate our molar mass of ammonium phosphate. Okay. She doesn't even have her periodic table out.
Well, I was pretty good Okay, ammonium. So, you want me to calculate it, or are you going to write it down and number it?
You're gonna do the whole calculation.
You're saying you can say it, I'll calculate it.
Do you know the formula of ammonium phosphate?
Well, can you write it?
I did. I just didn't know if you're paying attention or not. So it is up there. We should have at least one person verifying Sarah's work, because I don't know if I totally trust her. Okay, Michaela's got a backup for us.
Okay, I have to restart. Wait, Miss Russell, isn't it N4, right? And there's 3 of those.
Okay, after waiting for several hours, Sarah finally got her molar mass, which was, Sarah?
149.12.
149.12 grams per mole. And I'm going to write what kind of moles these are. These are NH4. We got 3 of those. And 1 phosphate. So following our units, we've got grams canceling out. We've got moles in the numerator. What do we want in the denominator?
We want liters.
We want liters.
So divide by 2 liters.
Yeah, do we know how many liters we have? So we are going to divide by 2 liters.
Boom.
Boom. So these are the moles per liter of ammonium phosphate.
Oh.
So we would be done if we just wanted the molarity of the whole compound.
Oh,
But what we do want,
just want it up in 4.
just of NH4. So we're gonna use a little bit of stoichiometry. So for every 1 ammonium phosphate, Vanessa, how many ammoniums do we have? 3. So all we're going to do is multiply this by that ratio. So we have 3 parts or moles of ammonium for every 1 part or mole of ammonium phosphate.
This lesson is just.
Well, it definitely is gibberish when you only pay attention to 30% of it.
I would pay attention to a much higher percentile.
I would not say that as a whole. We have video evidence we can go back and check. All right, so what happens to our moles of ammonium phosphate? They cancel. Do we have the units that we wanted now? Sarah's wondering if there are units.
You're left with moles of NH4 over liters.
Moles of NH4 plus over liters. Okay, so if you need to baby step this, you can baby step this with your calculator. You may not have to do that. You may be comfortable with entering your mass, dividing by your molar mass of 149.12, which took about an hour to calculate by some students, then dividing by our volume in liters, and multiplying by that stoic ratio of 3 over 1. And we get a concentration of 0.014887, etc. We're thinking about significant figures. Sarah has slipped back into not paying attention.
I don't understand why you rewrote the numbers.
Because I can never remember it when I go back to the thing. How many significant figures? 3. So what are we going to round our number to?
0.0149.
See, I still just think that it's a busy thing earlier. I would have just put 0.02.
Why is it 4? Why 2?
Okay,
So
so
rounded is the big number.
remember with significant figures, leading zeros are not significant. They just tell us our number is small. So the 3 digits that follow those are our significant digits.
Yeah.
What?
Well, number says 0.7. There's only one significant digit.
Yeah.
So there's a zeros in front.
We call them leading zeros.
That one.
Yeah.
They don't count any of the ones after it as long as there's no numbers between them.
Trailing zeros do count. So for instance, if we had the number 1.0000,
No,
that number would have
that would have 5
significant digits.
Because if
Get rid of the
it's
decimal.
0.004, then there's one significant digit.
Exactly, that would be one significant digit.
Got it.
We're done.
Okay, wait, but not if I do it. So 0.7 and 7.